Okay, we're looking at 2.5.15, and we need to prove that S is a primitive root of unity, then 1, S to the first, S to the second, etc., all the way to S to the n minus 1 are all distinct. So by definition, if S is a primitive nth root of unity, then n is the least integer such that S to the n is equivalent to 1. So let's assume by contradiction that we can get something else. We can do an S to the K, and let's say it's equivalent to S to the, well, K1 and K2. And let's also say that K2 is less than K1. Okay, so then what we're gonna do is we have this here, and then we're gonna go ahead and multiply by this. And then on this side, we're gonna get S to the K1 minus K2, and that's equivalent to 1. And then what we're gonna do is remember that K2 is less than K1. So when you subtract these, when you do K1 minus K2, you're gonna get something mod n that is less than n, right? And I think I'm gonna go ahead and add here, where K2 is less than K1 mod n. And so we get here and say that K1 minus K2 is less than n, right? We just kind of talked about that. But remember, S to the n is the least integer such that S to the n is equivalent to 1 mod n. So by contradiction, these things can't be equal. So right here, this can't work. So by contradiction, S to the K1 is not equivalent to S to the K2 when K1 and K2 are different.